Okay, so here we write a polynomial f of x with the zeros as -3, -1, 4, and 5, and it's of fourth degree polynomial. So I write down the function f of x or the polynomial f of x, and this equals for each of the zeros we have to create a linear factor. So I write down this in the form of x minus of -3 and multiplied with x minus of the second zero, which is -1, and then multiplied with another linear factor for the third zero, which is 4x minus 4, and then the last zero is 5, so it is x minus 5. Now let's simplify this. So this becomes x plus 3 times x plus 1, then times x minus 4 times x minus 5. So basically we have to multiply all the four linear factors and write down in the form of x power 4 plus x cube plus x squared plus x plus constant term with the corresponding coefficients. So first I'm going to multiply these two factors and then these two factors. We can easily multiply by first writing the x squared term, because we have a product of a linear term and another linear term. So the coefficient of x in both the linear terms are x. So therefore, it's going to be x squared. And then we add these two numbers, that is the n numbers 3 and 1. And then when we add it, we get 3 plus 1, which equals 4. So we write down this as a 4x. And then we multiply these two numbers, 3 and 1. The product of these two numbers is 3, so it is 3. So this is what we will get. We can also FOIL this, and even when we FOIL this, we'll get this expression. And similarly, we can multiply these two factors, x minus 4 and x minus 5. So I write down x squared first, then I add the two numbers, -4 and -5, and this equals -9. So I write -9 with x, that is -9x. Now I multiply -4 with -5, and this equals -20. I'm sorry, it is positive 20. So I put positive 20 here. Now we have to multiply these two factors. These are quadratic polynomials. So let's do that. We will multiply term by term. So first I'm going to consider x squared and multiply with all the terms in the second brackets. So therefore this becomes x squared times of x squared minus 9x plus 20. Now I consider the second term in the first bracket, that is this 4x, and then I have to multiply with all the terms inside the second bracket, that is x squared minus 9x plus 20. And now finally we have to consider the third term, that is 3 in the first bracket, multiply with second quadratic expression, that is x squared minus 9x plus 20. So let's distribute this x squared now, and we have to distribute to all the three terms. So therefore this becomes x squared times x squared is x power 4 minus of 9 times of x cube plus 20 times x squared. Now let's distribute this 4x with all the terms inside the brackets. So 4x times x squared is 4x cube. I'm going to write below this x cube term, and 4x times 9x is negative 36x squared. So I write down below this x squared term, and 4x times 20 is 80x. So I write down it here, 80x. Now let's distribute this 3 into the terms inside the bracket. So 3 times of x squared is 3x squared. I write down below the x squared term, and then 3 times negative 9x is negative 27x, and finally 3 times 20 is 60. Now we have to add the terms. So here we have only one x power 4 term, and here we have in this column negative 9x cube plus 4x cube, which is positive 5x cube. And now in this x squared like terms, we have to add the numbers or the coefficients, 20, negative 36 plus 3, and this equals negative 13x squared. So I write negative 13x squared. We then add all the subtraction of 80x with the 27x. And this equals a positive 53x plus the last number, that is 60. So therefore, this is the required polynomial given the four zeros of degree 4. Okay, there is a correction over here. This is not positive 5 because this is negative 9, positive 4 is negative 5x cube.